All right. I think did we stop here or the one before it? The one before it. Okay. I was trying to remember where we got to. All right. We want to find the sum of these two rational expressions. Now, for us to be able to add or subtract, we need the denominators to be the same. And for us to be able to get the denominators the same, we need to factor them completely so that we do get the least common multiple. We get the denominators to be the same, as small as possible. Because anything we go above the least common denominator, those factors are going to factor out later. Which sometimes, if it's just a number 2, 4, 6, 8, any even or odd, it doesn't matter. Number is easy to factor out. It's easy to divide a number out. But if we get other factors, we're going to have to factor it down, which can sometimes be a little bit harder to see. Now, the 12x squared is as simplified as it gets. The x squared plus x has the greatest common factor of, well, x. And we can factor that x out of both terms. So it's going to take it from x squared to x and from x to 1. Whenever something factors out completely, it reduces to 1. Least common denominator. So we have two denominators that we're trying to get to be the same, 12x squared and x times x plus 1. So we can start with our number. And one of them, well, we have 12. The other, we just have 1. So part of the least common denominator is going to have to be 12. That's kind of nice. We're not trying to compare two different numbers. Our next piece is our x squared and x. In one of them, we have 2 x's. The other, we have 1. Which one has the most? The one on the left with 2. So that means our least common denominator has to contain 2 x's or x squared. The only other factor we haven't looked at is the x plus 1. And since it does show up once in one of them, we're going to need it once. So that tells us that the two denominators both need to be 12x squared times x plus 1 for us to be able to add these two together, because the denominators have to be the same for us to be able to add or subtract. All right. Now let's look back at both of these and see what they're missing. Now the one on the left, we already have the 12x squared taken care of. That already matches up. What is it missing, though? The x plus 1. So we're going to have to multiply x plus 1 on top and bottom so that we do have the denominators 12x squared times x plus 1. And we're going to have to multiply the numerator by it as well. So if we do this multiplication, 8 times x is going to be 8x. 8 times 1 is going to give us plus 8. Now, if we look at our other rational expression, the x plus 1 already matches up. However, we have x instead of 12x squared. So to get the x to become x squared, we're going to have to multiply the top and bottom by x. We're also going to have to multiply the top and bottom by 12. Because if we multiply the denominator, the x times x plus 1, by 12x, we do indeed get 12x squared times x plus 1. On top, x times 12x is 12x squared. Now at this point here, it might be very tempting to want to simplify the 12x squared and 12x squared out because they are in common on top and bottom. However, we can't, because if we did simplify this, that would go away, the top would become 1. Are the denominators still the same? No. So we can't add and subtract if the denominators aren't the same. It's very tempting to want to do it. but we have to leave that there because once we start the process of getting the denominators the same to be able to add or subtract, we can't start simplifying until after we've actually added and subtracted the terms together. Now, since they are the same, we can go on and start adding these two together. Since the denominators are the same, we can make them one fraction with the same denominator, our 12x squared times x plus 1, and we can add the numerators. Now for us here, since we're adding, the parentheses around the 8x plus 8, we can drop those because there's not a sign in front of it, so the signs aren't going to change. And the signs with 12x squared aren't going to change either. So really we're saying that we have 8x plus 8 plus 12x squared. Are there any like terms on top? No. So we can just write it in standard form. Put the variable with the biggest exponent first. So then we'd have x squared x and then our constant term over this here. Oh, too far down. Questions on any of this so far? Now the only thing that we have left to do is seeing if the numerator will simplify it all with the denominator. Now again, it's going to be tempting to want to cross out that 12x squared and 12x squared. But if the terms are being added together, not multiplied with each other, we can't just cross it out. So first thing we need to look for on top is greatest common factor. Is there a number or variable that will go into 12x squared, 8x, and 8? 4. So we can factor it out. If we factor the 4 out of 12x squared, we're left with 3x squared. Factor the 4 out of 8x, we're left with 2x. And 4 out of 8 is 2. Incidentally, 3x squared plus 2x plus 2 won't factor. The only way that it would factor in this form is if the 3x was either 5x or 7x. That's the only way it would actually factor. In this form, it doesn't factor. But let's look at the top there. The 4 is now being multiplied by that set of parentheses. We can simplify the 4 and the 12. Because really what we're saying is that, or how I could write this is 4/12 times our 3x squared plus 2x plus 2 over our x squared times x plus 1. Because that multiplication, we can split and combine those how we want. We cannot do that with addition and subtraction. Because when we add or subtract two things, the denominators have to be the same. So if I were to split it up with addition, it means we'd have 3x squared over the x squared times x plus 1, plus 2x over the x squared times x plus 1. We split it into multiple fractions. It's not making it simpler. It's making it more complex. Multiplication, we can just pull the parts that we want. And 4 over 12 is going to reduce to 1 over 3. So on bottom, we would have 3x squared times x plus 1. On top, since it reduced to 1, we just have our parentheses left, our 3x squared plus 2x plus 2. Questions on this here, this addition subtraction? We ready for the next one? Finding the difference. X plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. Now, there's no reason for us to factor the tops of these fractions, no matter if they do factor. Because as we've seen up to this point, if there are common factors when we do the addition subtraction part, we're going to have to add or subtract. We're going to have to combine like terms. So if we did factor the tops of these fractions, for us to be able to add or subtract, we're going to have to unfactor them to be able to add or subtract and then factor them again. I feel like that's a lot of unnecessary work just to get there. The reverse is true. The denominators, we're going to factor them. So our 2x minus 2 is the greatest common factor of 2. Now, once we do the multiplication step, we could multiply through. But if there's something in common on top and bottom, we'll have to factor the denominators back out. But even when we do our subtraction step, the denominators stay the same. So there's not a whole lot of reason to distribute through the bottom because we're not having to add or subtract. We're not having to combine like terms. So it's better to leave that in factored form. Even if nothing factors, we factored it. Leave it there. There's no reason to do that. It's extra work, unnecessary work. At least I think so anyways. The other one we need to factor is x squared minus 4x plus 3. Now, there is no greatest common factor between these three terms. One way we can tell is, well, x squared doesn't have a number in front of it. 3 doesn't have an x. Our signs. Since the third term is positive, the signs are the same and match the sign of the middle term. Negative and negative. Now, our factors of x squared only has one set. X and x. Factors of 3. 3 and 1. Again, only one set of factors for 3. Plug them in. And the nice thing with the signs being the same, doesn't matter which way we put it, it's going to be the same answer. And if we check the middle term, x times negative 1 be negative x. Negative 3 times x is negative 3x, giving us the negative 4x, which is indeed our middle term. So it is the correct set of factors. Least common denominator. Well, one of them has a 2 outside the parentheses. Does the other one have a number outside the parentheses? No, so we know what has to be in common. 2. The only reason we're checking to make sure there's not another number is I'm not having to match it with something else. Because if there was a 3 out in front of the others, we'd have to find the first number we can turn both 2 and 3 into going up, which would be 6. That would be our least common denominator. Here, there's only one number, so it's just 2. X minus 1, that factor does show up in both. How many times does it show up in each one as a factor? Once. Even though it shows up in both, it only shows up in each one once, so we only need it once. And the only other factor that shows up is x minus 3. It only shows up in one of them once, so we only need it once. So let's see what we're missing. Because both of them are going to end up being 2 times x minus 1 times x minus 3. Now the one on the left does have the 2, it does have the x minus 1. It is missing the x minus 3. And if we go on and multiply it, because we can multiply it at this point, first thing we're going to do is distribute the x. Our x times x is going to be x squared. Let's save the cube for a little bit now. It's just a little loud. Oh, you're good. X times 2 is plus 2x. Our negative 3 times x would be negative 3x. And lastly, negative 3 times 2 is going to be negative 6. And luckily, the multiplication on bottom, we just get 2 times x minus 1 times x minus 3. Now let's look at the other side. Our other rational expression does have the x minus 3. It does have the x minus 1. The only thing it's missing is the 2. And we can distribute the 2 through this here. Our 2 times our negative 2x is going to be negative 4x. Our 2 times our negative 1 is going to be negative 2. Now, before we start adding, I feel like it's going to be a good step to combine like terms so we don't have multiple terms showing up in the same spot. And the only place that we do have like terms is our first rational expression, our 2 minus 3x. And 2 minus 3x is negative x. Yep. Questions on this so far before we start subtracting? So since we have the denominators the same and our numerators are simplified as far as we can without factoring, we can go on and subtract the two numerators. Now with addition, it wasn't too big of a concern with our parentheses. But with subtraction, this negative is going to have to be applied to both terms. We're applying that negative through, which means our negative 4x is now going to become positive 4x. Our negative 2 is now going to become positive 2. Because what we're saying is that we're subtracting negative 4x. We're subtracting 2. That negative negative makes a positive. Now we're going to combine like terms. Our negative x plus 4x is going to be plus 3x. Our negative 6 plus 2 is going to be negative 4. Questions on how we got to this point here? Last thing we need to do is factor this. And the numerator will factor. Since our third term is negative, the signs are going to be opposite. One's going to be positive, one's going to be negative. Our factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. Now the nice thing with rational expressions is the denominator gives us a hint. Because if something's going to factor or simplify out, I need one of the top parentheses to be one of two things. Either x minus 1 or x minus 3 for something to cancel. X minus 3 we can throw out because 3 is not a factor of 4. So the only one that will simplify is x minus 1. 1 is a possible factor of 4, and we'd have to put it with the minus. But that means our other factor of 4 is 4. So if this is going to simplify, if it's going to factor, it's going to have to be x plus 4 times x minus 1. And I'm going to check it off to the side. X times negative 1 is negative x. 4 times x is plus 4x. Giving us the positive 3x middle term that we want, which means for us the x minus 1 and x minus 1 are going to cancel, telling us that we have x plus 4 over 2 times x minus 3. And that's as simplified as it gets. Now there is no reason for us to multiply the 2 back through the x minus 3 to tell us that we have 2x minus 6. It's simplified. There's nothing else we can do with it. That's as far as I want you to take it. Questions on this here? We have 2 problems left, this one and one more. And we're done with these notes. Well, 3 more. One of them is going to be even faster than the rest. So, first thing again, we're going to have to factor the bottoms, factor the denominators. Now to both of them, one of them is nicer than the other. And that's the 2x minus 4. Because there's a greatest common factor of 2. So it gives us 2 times x minus 2. That's kind of nice. It's tackle the ones with greatest common factors first. The other one, again, doesn't have a greatest common factor. So we got 2 sets of parentheses with 3 spaces. Since the third term's positive, the signs are the same and match the sign of the middle term. Negative and negative. Only factors of x squared are x and x. Well, the only factors of 2 are 1 and 2. Questions on this so far? Now, we are going to have to get the denominators the same. We're looking for that least common denominator, yes? There are, I'm going to show you this here. This is kind of a nice way to look at it, and it works well with these, with polynomials. It doesn't work well with numbers. In that, with numbers, we have to actually figure it out. We need to find the factors and look at them and see. Here, let's look at the one on the left. It has an x minus 1 and an x minus 2, yes? What doesn't the one on the right have out of those 2? X minus 1, so the one on the right has to have a 1. X minus 1, it's missing it. It has the x minus 2 already. Those match up. It's missing that x minus 1, yes? Okay. Let's go the other way. What does the one on the right have that the one on the left doesn't? Well, because we gave it the x minus 1, yes? Only thing it's missing is the, yeah. That's the nice thing with these polynomials, is I can just look at the bottoms. What does this have that that one doesn't? Okay, let's give it that. What does this one have that this one doesn't? Let's put this on it. That's really all we've been doing. Because when we multiply the bottoms, it's going to be 2 times x minus 1 times x minus 2. Let's multiply the top here. 2 times 5x is 10x. 2 times negative 1 is negative 2. Now on the other side, we do have 2 binomials, two terms. We're going to have to multiply this out. We'll have negative 2x times x, which is going to be negative 2x squared. Then we'll have negative 2x times negative 1, which is going to be plus 2x. Then we're going to have negative 1 times x, which is negative x. And negative 1 times negative 1 is plus 1. X minus 2. Nothing really we can do with it. It's just 10x minus 2. The only things we can do with it is factoring, but that's not going forward. That's going to be going backwards. The other side, we can combine like terms. We'll still have the negative 2x squared. But our 2x minus x is going to be plus x plus 1. Now, since our denominators are the same, we can put them as one fraction with that common denominator on bottom. And we can subtract the numerator. Now our first set of parentheses is going to stay 10x minus 2. Sign in front of it's positive, it's a plus. We don't write it, but it's understood. But we will have to distribute that negative through. So our negative applied to that negative 2x squared is going to become plus 2x squared. Our negative applied to our positive x is going to become negative x. And that negative applied to the positive 1 is going to make it negative 1. Yes. Yes. Now we combine like terms. 2x squared, our x squared term doesn't have any like terms, so it's going to be 2x squared. 10x minus x is going to become plus 9x. And negative 2 minus 1 is negative 3. So, questions on how we got to this point here before we start trying to simplify? Is there a common factor between 2x squared, 9x, and 3? Remember that we're going to all 3. No. And it doesn't look like, because again, that middle term is decently big, 9 compared to 2 and 3. So it's kind of questionable if we can actually factor this. So again, our check is our b squared minus 4ac. Now we don't actually have to write this out or write this anywhere. It's more we grab a calculator and check it. See if this will factor. Because if we do get a number without a decimal, don't get a domain error in our 30xs, then it does factor. Second square root 9 squared minus 4 times 2 times negative 3. Well, I don't know what root that took. I need to take, that's not a whole number, that's a decimal, so it doesn't work. Ah, okay. What it gave us the first time was the square root of 21 over 7 roots of our number. So. It means that numerator is not factorable. That is as far as it goes. Questions on this here? All right, guys. Questions on this so far? Questions on anything we've done so far? We good? We're doing this and one more. I know I said 2, but I want to hit this one real quick because one of the things is that we can actually hit this one pretty quick. Because again, the denominators aren't the same. We can see that already. 4x and 7 are not the same. Can we factor 4x? No, it's one term. Can we factor 7? No. 3 and 7, do they have anything in common? No, there's no greatest common factor. There's no common terms between them. So literally the only thing we can do is multiply the one on the left by 7 over 7 and the one on the right by 4x over 4x. Now the denominator, 7 times 4x is 28x. 7 times 4x is still 28x. On top, 7 times 3 is 21. 1 times 4x is 4x. Denominators are the same. We don't have anything we can simplify on top. Now we can put parentheses around it, but again, the reason we don't necessarily have to on this one is how many terms do we have on each top? 1. So really we apply that negative through the second numerator, negative 4x. Because we can put the parentheses You don't have to. And then we say, okay, the 21 stays positive, the 4x is now negative, and we get to the exact same spot. There's not a whole lot of reason to do it because we have applied it. We know that we're applying that negative to it. All right, 21 and 4x is their greatest common factor. Now, the only factors of 4 are 1, 2, and 4. 1 doesn't make a difference because factoring 1 out doesn't change a thing. 21 does not divide by 2 or, so we're out of factors. Which means that's it. Questions on this here? Would it be safe to say that there's a lot to addition and subtraction, but not a lot at the same time? I mean, there's more than most, but there is a lot of it's just repetitive factoring, simplifying, factoring, simplifying, factoring, simplifying. It's a lot of steps. And for one of the few times we can say that dividing is more simple or simpler than addition and subtraction. There's less to dividing than there is to adding and subtracting. An odd statement to make, but I don't think y'all would disagree. Because dividing, we keep, change, flip, multiply. Questions on this here?
All the questions are questions we did review.
Okay. We're going to look at one more. And I want this color here. Hang on. There we go. I want to change the top of this to I want to change it to x squared minus 8x plus 32. I want to change that second numerator. I'm changing it not because the original problem doesn't work. The original problem works well. We just didn't have time to get to factoring by grouping. We would have to factor by grouping as it was originally. We're going to leave it as, I want to change it to this here. Now, again, our numerators, we're going to leave them as they are. Because x squared minus 8x plus 32 doesn't factor. It feels like it should, but it doesn't. 132, 2 and 16, 4 and 8. Yep, it doesn't factor. Seems like it should, but it doesn't. Even if it does, there's no reason to. X minus 4. Simplified as it gets, or as simple as it gets. X, can't simplify it any further. X squared minus 16 will factor to x plus 4 and x minus 4. Least common denominator, we need to get them all to be the same, yes? Now if we start on the far left, it has a factor of x minus 4 how many times? Once, which means that every denominator needs to have it at least once, yes? Does the middle one have it once? No, so we're going to have to add an x minus 4. We're going to have to multiply by x minus 4. Does our third one have an x minus 4 as a factor on bottom? Yeah, because it has x minus 4 written there, yes? If we do have it, does it show up more than once? No, so all of them should only have it once, because if it shows up more than once, we need it more than once. If it doesn't, we only need it once. So that takes care of all the factors of the first one that we have. The middle one has an x, which means all of them are going to need an x. And besides the middle term, It's the only one that has an x, so the outer two have to have x. Are there any other factors we haven't covered? Oh, the x plus 4. And again, I would leave these denominators factored. There's not a whole lot of reason to factor. There's actually no reason to factor them that I can see. Now, some of the online programs or programs that you can look at for doing these or showing you how to do these, they're going to multiply it through. Not a whole lot of reason to. I don't see it. Now on top, we're going to have to multiply to combine like terms. I'm going to start on the far right. Because the only thing that we're multiplying through by is this x. So x squared times x is x cubed. Negative x times x is negative 8x squared. And 32 times x is going to be 32x. Really all we did was distribute that x. The middle, we have to pick what we want to do. I would not multiply all three at once. That's a little too much to do all at once. Because even though that the number is 2, I would multiply the x minus 4 and x plus 4 together. Does anybody know off the top of their head what x minus 4 times x plus 4 is?
Probably 0x1 or 4. That's my guess.
So we'll go on and multiply it out, and I'll show you. There's a way to actually know this. X times x is x squared. X times 4 is going to be plus 4x. Negative 4 times x is going to be negative 4x. And negative 4 times 4 is going to be negative 16. We'll combine like terms here in a minute. And the last one, we have some choices. I can either multiply the x and x plus 4 first, and multiply what we get with the x plus 2, or x minus 2, or we can just multiply. I'm just going to multiply the x plus 4 and x minus 2 first. Because when we multiply through by x, it's just increasing the degree of the variable, or giving it one. X times x is x squared. X times negative 2 is negative 2x. 4 times x is going to be plus 4x. And 4 times negative 2 is negative 8. Now the middle one, our x squared plus 4x minus 4x minus 16. Well, the 4x and negative 4x is going to be what? 0, telling us that we have x squared minus 16. Our first one, negative 2x plus 4x, is going to be plus 2x minus 8. Now again, I said I would tell you there's a way that we could have really jumped from our 2 times x plus 4 times x minus 4 to 2 times x squared minus 16. Where did we get the x plus 4 and x minus 4 from? Well, it's the factors of x squared minus 16, yes? So x squared minus 16 factored to x plus 4 times x minus 4. So doesn't that mean it'll multiply back together to be x squared minus 16? So, interesting thing to note, because it could cut out a step if we see that we factored them earlier. Last thing we have to do is finish simplifying these numerators. Here we can distribute the x. X times x squared is x cubed. X times 2x is going to be plus 2x squared. And x times negative 8 is going to be negative 8x. Here we can distribute the 2. 2 times x squared is 2x squared. 2 times negative 16 is going to be negative 32. Nope. Got them all simplified, combined like terms. Now we can actually add and subtract the numerators. Now we don't have to do this individually, do the first two and then the next one. We can actually add and subtract all of our numerators at the same time. Out of these three here, the one that we have to be careful with our signs is the third one, the one we're subtracting. Because here we're going to have to distribute that through. It's going to make our x cubed negative. It's going to make our 8x squared, that should be squared, positive 8x squared. And it'll make our negative 32x, or 32x negative. Questions on this here? We do have a lot of terms on top. We're in combined like terms. I always start with the variable with the biggest exponent. X cubed minus x cubed is 0. There, gone. Our next term is our squared. Well, we have 2x squared plus 2x squared is 4x squared, plus 8x squared is 12x squared. Those are taken care of. Our next one is x. We have negative 8x minus 32x. Negative 8 minus 32 is negative 40x. And lastly, we just have negative 32. And yes, I think, probably been alternating the x minus 4x plus 4. That really doesn't make a difference, as long as we still have both of those listed. Greatest common factor between 12x squared, negative 40x, and 32. Negative 32. 4, yes? So we can factor it out. Giving us 3x squared minus 10x minus 8 over x Interestingly enough, this is one of the first ones where we had a number in front of x squared, not variable, number in front of x squared, and it factors, because all the rest have just been, they don't factor. Now the steps are still the same. Since the third term is negative, our signs are opposite. Now this is the first time we've actually had a number in front of that x squared, yes? So this is how I look at it. So 3x squared, we're trying to find the factors of it, the factors of the first term, yes? Now looking at both of those, what are the only factors of x squared? X and x. And instead of looking at all the factors with the 3, I know each one, both factors are going to have x and x each time. There's only one set, let's throw them in. That way I'm not looking at the factors of 3x squared, we're just looking at the factors of 3 now. Less to work with. Now we're going to have to pick one of these two. I'm going to pick the first one. Doesn't really matter at this point because, again, we check to make sure to see if it works. Factors of 8, there's a few. 1 and 8, 2 and 4. Now, if we're going to have something match up, possibly match up, I need one of these to either be x minus 4 or x plus 4. Well, the way we have it written, the only one that could line up is x minus 4. So we can put the 4 with the minus, 2 with the plus, and check here. 3x times negative 4 is negative 12x. 2 times x is plus 2x, giving us negative 10x. That is the middle term we wanted, yes? There is something in common on top and bottom. It's the x minus 4. Telling us what we have left is 4 times 3x plus 2 over x times x plus 4. And that's as simplified as it gets. There's no reason to multiply the x back through the bottom, giving us x squared plus 4x, or multiplying that 4 back through, giving us 12x plus 8. That's simplified. It's done. We don't have to do anything else to it. I will say that this is more steps than having just 2, but is it any harder than just having 2? Not really. A lot more steps. But personally, I don't classify more steps as harder. There's just more to do. Questions on this here? We do not have a 4th day of this. That's it for this here.